Hi everyone, let's solve this problem. Generate parentheses. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So let's take the simple example first. If n is equals to 1, a well-formed parenthesis will be like one opening parenthesis and one closing parenthesis. And similarly, when n is 3, this is how this is all the well-formed parentheses. Now let's try to understand for n is equals to 3 with a tree. Let's say for example, let's also discuss few things before. When n is equals to 3, open parenthesis should be 3, close parenthesis should be 3. Now when this is not just the criteria, because let's say I have 3 closing and 3 opening. Is this a well formed parenthesis? No. Let's say for example this is also not a well formed parenthesis. So now let's try to understand when does it is a well formed one. So open should be exactly 3 if n is equals to 3, and close should be always less than open. Let's say for example 1, 2, 3, it's a valid one, right? So far it is valid. Later if I put a single open parenthesis, it's still valid. Let's say, but in this case I put closing parenthesis, it's still valid because we can put opening and closing. But let's say I have a closing parenthesis again. Now open count here is 1, 2, close is 3. So no matter in which example we take, close parenthesis, if it is greater than open, then it is not a valid one, so we cannot move forward. So now let's try to understand it with the tree by taking n is equals to 3. Let's maintain our open as at max 3 should be at max 3, and close should be always less than open. So I'll start. Initially we know that we cannot have a close parenthesis because of this condition, so it will be open parenthesis. Now here I have two possibilities: open, 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 close. Then I have open, 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 and at every point we have either we can choose open or close. It depends on these conditions. Now it will be close. Now again I have a condition now. So in this case there is only one choice for us, because we cannot put any open parenthesis anymore, because we have already covered our maximum limit for open parenthesis, which is 3. So we will have to just close it. Then for this we still have two options. One is open, one is close. In this I just have one operation, which is close. In this case again we are done with 3 of the operations, 3 open parentheses. So I will have to any which ways add a closing parenthesis. So there is only one decision left here. It has two decisions in this case: open, close, open, 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 close, close. Okay, there will be only one because we cannot put a closing parenthesis before opening. Then in this case again there is only one choice. This case also there will be only one choice of closing. In this case as well there will be only one possibility of closing. Now let's try to repeat the process. Open, there is no possibility of closing because it's not allowed to have a closing more than the opening. So in this case it's just open, close and open. And at this point, close, open, 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 close, open, close. At this point, 3 of them are done. 3 openings are done. There is only possibility of closing. So we are done here. There is no possibility of closing here because we cannot close without having a opening brace. So it will be open, close, open, close, open. And in this case again there is only single possibility, open, open, close, close. And in this case there will be only one possibility, right? So let's see our example. 1, 2, 3, 4, 5. These are the possible well-formed parentheses, and we are able to get the answer if you see these ones. So we will stop when we reach open is equals to 3 and close is also equal to 3. Now let's try to write the code for this for understanding it better. So we will have a result array, and then we will write a backtrack function which has open, close and result current. So now in this case I will have to check if, since we are going to start our indexes from 0, I can just write open is less than n. Only then I will call my backtrack function with open plus 1 because we are going to add open and n and result, and current will be, I will be just adding my open parenthesis, right? And if close is less than open, only then add a close parenthesis, backtrack of open, close plus 1 because we are adding the closed parenthesis, and current will be current plus closing parenthesis here. Now what will be our base case? If open double equal to n and n close is double equal to triple equal to n, in this case what will happen? We will push our current string into our current array, and rest all should be good enough, and we just have to return from here because we don't have to move forward after finishing this step. Now at this stage I will call my backtrack function with open as 0, close as 0, n as whatever is passed, and result array, and I will pass current as an empty string. Then I will be returning the result. Now let's try to run it up. Let's submit it. I hope the solution is clear. Thank you.